In this video, we're going to look at compound interest. So first, let's see what you're given in the formula booklet. You're given the formula for compound interest, which is FV is equal to PV times 1 plus R over 100k raised to the power of kn, where FV is the future value, PV is the present value, what it's worth now, N is the number of years, K is the number of compounding periods each year. So if it's compounded every year, K would be 1. If it's compounded every 6 months, K would be 2. If it's compounded every quarter, K would be 4. And R% is the nominal annual rate of interest. Let's look at a typical exam question. In 2019, Mr. James invested $12,000 with his bank at 5.2% per annum. Interest compounded every 6 months. A. Calculate the amount in his account after 10 years. So let's first write down everything we've got. Well, the future value, well, that's what we want to find. The present value is equal to 12,000. The number of years is equal to 10. K is the number of compound periods. Well, that is equal to 2. And R, the interest rate, is equal to 5.2. So let's put everything into the formula. So we get the future value is equal to the present value, which is 12,000, times, let's open brackets, 1 plus 5.2 over 100 times K, which is 2, raised to the power of Kn. Well, N is 10 and K is 2, so that's 2 times 10. We can use our GDC to solve that question. So we've opened the GDC at a calculator page. So we want to type in 12,000 times, open brackets, 1 plus, we want a fraction, so control divide, 5.2, so 5.2 divided by 100 times 2, so I'll just type in 200, come out of the bracket, we want it raised to the power of 2 times 10, which is 20, press enter, so after 10 years we will have $20,050.70. So let's write down our future value. So the future value is equal to $20,050.70. Make sure, because we're dealing with money, it is to 2 decimal places. Part B. In which year will he have doubled his money? Well, to double his money, the future value must now be equal to 24,000. That's 2 times 12. So the present value is 12,000. N, well, we don't know that. That's what we want to find. Well, it's compounding every 6 months, that's 2. We know that the interest rate is still 5.2. So again, we could put that straight into the formula. So the future value is 24,000. Well, that is equal to 12,000 times 1 plus 5.2 over 200 to the power of 2n. We're trying to find n, and in order to do that, I'm going to use nsolve on my GDC. I've reopened my GDC, so now I want to find nsolve, which is menu, algebra, numerical solve. Type in the equation exactly, so 24,000 equals 12,000 times, open brackets, 1 plus, I want a fraction, so I go control divide, 5.2 divided by 200, come out of the brackets, to the power of 2x. I want to solve for x, so comma x, come out of the bracket, press enter. So my amount will be doubled after 13.5 years. Now we need to answer the question, in which year will it have doubled his money? Well, when n is equal to 1, that is at the end of 2019. When n is 2, that is the end of 2020. When n is 3, that is at the end of 2021. And if you go all the way up to when n is 13, that will be 2031. But we need a little bit more than 13. We need 13.5. So we need when n is 14, which will occur in the year 2032. On the GDC, we also have another tool in our armor that will help us with compound interest type problems. We have the financial solver. So let's go back to question B and use the financial solver to solve the question. I'm back at the GDC, so I want to find the financial solver. So hit menu, function 8, 1, financial solver. So if we put in all our information, we have an interest rate of 5.2. We have a present value of 12,000. There's no more payments. The future value is minus 24,000. It doesn't matter which way round you put the positive and the negative, but one must be positive, one must be negative. We have payments per year as 2. We had compounds per year as 2. Now if we highlight N and press enter, that will give us 27. But remember, that is for 2x, so we have to divide by 2 because we're compounding every 6 months, so that will give us the answer of 13.5.